Types of products you can produce with these. You guys are probably more than familiar with a lot of these. Concept models all the way to end-use parts. This area right here, I think, is really one of the biggest areas that's been untapped by a lot of this. Jigs and fixtures. How many people have seen a manufacturing process that doesn't use any sort of tool holding? But we've got CAD data. We can pull a tool, we can pull all the geometry to nest and cradle apart in seconds. And you've got all the data you need to move right to it. Very quick, simple, and they're all low volume. You're not producing millions of them, you're producing enough for a production line. If it wears out and you have electronic data, you put it into a machine, you build another one, you put it in service. Quick and simple applications, low-hanging fruit. So, some product examples here. I mean, these are just a variety of different things. This is a stereolithography part that basically had an extensive amount of bench work done to it to polish it up so that it could do light transmission. So that's some of what's capable with these. This one here was polished up and it has all these rotors and core plates in this hydraulics manifold so that you can see where all the fluids are going. Variety of different applications, and then over here you've got the surface of a tool that can be produced by stereolithography. So these different options are available if you're applying. But one thing we have to consider is these are all additive processes. They all build in layers. So you're going to have, no matter what process it is, you're going to have stair steps. Some of them are going to have powder, some of them are going to have porosity. How do you manage that, and how does that impact the application of the product that you want to put into service? Taking a look into these considerations, is it something that you go through and you do in a finishing operation afterwards? Or do you just accept that these are the stair steps that I'm going to have, and let's orient or design the part to accommodate for that? What you do with these, what sort of resolution you go with, is going to impact the cost. Number of parts that you're making, any validation procedures, any sort of failures that you're going to wind up having are all cost drivers. Then you've got a variety of secondary operations, which are very similar to any other process that already exists. So you can put finishing, infiltrating, plating, sealing on any of these different pieces, so just like you would any regular part. So these are all still options. Don't dismiss them or anything. A lot of people look at this as, I want to be able to pull it straight off the machine, I want to put it together, and I want to make it work. And that's it. But we don't do that with anything else. We don't take a forging and just put it right into service. We're going through and we're doing finishing operations on these. So why not take these finishing options that are available into consideration for these? Here's an example courtesy of Chrysler Corp. They're basically using your standard quality control layouts, and then they're using Magix or Materializes rapid fit option to basically take the STL file to known data points and say, okay, build me a post. And it outputs an STL file that you can take and put on any machine. Chrysler's doing it with SLA here because that's what they wanted to. But now you've got simple little posts that you can put up into an inspection area. So now you can set it up, do all your QC analysis and evaluation, and when you're done, you don't need to save these if you don't want. You can scrap them and build another set if you have to come back to them. You've got the electronic data files. You don't need to necessarily worry about all the management of it. Or you can tag them and save them and bring it back.